Starting from where we left, we were solving this question. Um, so we have to form a relation R. Yeah. So we have discussed about first sets. Sets are a well-defined collection of distinct objects, right? And with the help of set, we can do some operations. We can actually connect two sets, and there are two rules to do so. One is relations, and second is functions. Right. So let's start with the question again and revise the basics of class 11. So let's say we are given these two sets. Can you solve these two questions first? So we have the set A and set B. Set A is 1, 2, 3, and set B is 4, 2. Then we have to find B cross B and we have to find A cross B. And then we have to form a relation R. Then we have to form a relation R of the ordered pair x, y. And the relation to x and y is x is equals to rather x should be greater than y. X should be greater than equal to y, where x belongs to set A and y belongs to set B. Please try to solve these three questions. Now let's start with the first one. What is B cross B? Now, how do we find out B cross B? Can someone tell me? B cross B means we have to form an ordered pair. The answer would be an ordered pair. Ordered pair is like 1, 2, something like that. 3, 4. Right? When there are two elements clubbed together in a square bracket. So this is an ordered pair. Now, ordered pair, we have to form an ordered pair whenever we have written these kind of things, either relation or function, or this is Cartesian product, right? Cartesian product of two sets. So in case of this, we have to form an ordered pair. Ordered pair will be something like this element, where first element will be coming from B and second element will also be coming from B. The order is same. If it's written B cross B, then first element will be from B and second element will be from B. And there is no condition. You just have to form all the ordered pairs. In case of Cartesian product, if you are finding out the Cartesian product of two sets, then you have to form all the pairs which are possible with those two sets written there. So in this case, we are given set. We have to find out B cross B, and set B is also given to us. Set B contains two elements, 4, 2. So we have to basically relate each element with itself. Is it better now, Shahid?
Mostly the same.
Okay. Yeah. So I'll try to speak louder now. We have to find out B cross B, and to find out B cross B, both of the elements should be from B, right? First element and second element. Now B contains two elements, 4, 2. So we have to basically relate each element with itself. So first we will take one element from B, right? And then we will exhaust all the possibilities of set B. So we will take 4, then we will connect 4 with 4, and then 4, 4 with 4, 2. So first element from B, I have taken 4. Now I'm changing the second element. I'm taking second element also from B. We have two options in B, 4 and 2. So there are two ordered pairs, 4, 4 and 4, 2. Then I'll take 2 from the set B. So I have two choice from here and two same from here. Right. So there are total possible 4 elements which can be made here. So it will be 2, 4 and 2, 2. So that is how we can find out the Cartesian product of two sets. Now, if I find out A cross B, then I have 3 possibilities from A and 2 possibilities from B. So there will be total 6 elements which can be formed. So let's take one from A. While forming this, let's take one from A. Then I can either choose 4 from B or I can choose 2 from B, right? First element should be from A and second element should be from B. Now taking 2 from A, then I got 2, 4 here and 2, 2. I can also take 3. So it should be 3, 4 and 3, 2. So that is how we can find out the Cartesian product of two sets. And if I want to find out the relation, now let's focus on this part more, because relation will be, you will have to form certain relations. You'll be given some condition, some relation in a set builder form, and then you have to convert that set builder form into roster form, right? So this right now relation is written in the set builder form only, in which you're given a pair x comma y, which follows this relationship that x is always greater than equal to y, where x is the element of A and y is the element of B. So to form a relation, we have talked about this in the last class also. To form a relation, either you can fix x or you can fix y. You fix one thing and then you try changing the other for all the options, right? So in this case, you can either choose x or y. Let's start with y, because y has less elements than A. So we will have to check for less points, right? So in this case, you have x as 1, 2, 3. You can choose x from 1 to 3, right? Because x belongs to A. And your y belongs to B. So y is an element from this 4, 2. You can also write it as 2, 4. Both are same things, right? So choose one y. Let's choose 4. So x greater than equal to 4. If there is some x from the available domain which satisfies this condition, right? So in that case, that would be a solution of the relation. So x greater than equal to 4, there is no value of x greater than equal to 4 here, because we have 1, 2, 3 only. 1, 2, 3 are the only options. So in this case, no solution. For 4, if you choose y4, right? Now if I choose y2, if y is equals to 2, then the condition x has to follow should be this x greater than equal to 2. I have two options for this. X can take the value 2 or x can take the value 3. So first case, I didn't have any solution, but in the second case, when I change the value of y, in that case, there are two possible values of x, 2 and 3. So the solution should be in the form of x comma y. So there is 2, then 2. Then there is another value of x, which is 3, with the same value of y, 2. This is our relation. 2 comma 2, 3 comma 2. So to find out any relation, you will have to fix one variable and then iterate the other variable around that variable, around that value. Now just solve 2 more question, because we'll be solving a lot of relation. We should know how to form a relation. Now let's start forming some relation. Form a relation R such that x is equals to y plus minus 1, where x belongs to, or rather x comma y both belongs to set A. Try to solve this one. We have to form this relation x comma y, which follows this, that x, the value of x, should be equal to y plus minus 1, right? And x and y both value give you better understanding of the concept. Because if you know how to form a relation, then the topic is quite easy. You can understand it. What are the we will have to basically discuss the types of relation. But before discussing the types of relation, we need to form those relations. We should be good with the questions part. Now try to form some relation. You're given a certain rule, follow that rule, fix one variable, give it anything, and then try to find out the value for that. So पहले y को कोई एक वैल्यू दो, x निकालो पॉसिबल क्या क्या हो सकता है, फिर ऐसी y को दूसरी वैल्यू दो, give the keep changing the values of y and try to find out the answer for each and every value which is possible. Good, Austin. Answer is correct. Yes, what should be the answer? Faiza, Humamuddin, Tarif, Shahid, and Chavez. So how many options do we have for the values of x and y? There are 3 options, right? First question should be this, that what are the possible values of x and y? As it's given that x and y both are from set A, तो यहाँ से क्लियर हो गया कि यार x और y को सेट A के अंदर से उठाना है, तो 1 2 3 हमारे पास 3 ऑप्शन है ना। चेक करो जो भी सेकंड वैल्यू आ रही है क्या वो हमारे सेट को बिलोंग करती है। So let's say y is 1. Now both x and y are from set A. So if y is 1, we have set A, B, right? In the above 1, 2, 3, and 4, comma 2. But it's given that you have to only form the relation on set A. So let's start with the values of set A. तो y की वैल्यू पहले रखते हैं 1, y को 1 पुट किया तो x का वैल्यू बनता है 1 plus minus 1. You put y is equals to 1 at this place. So there are two possible answers, right? If 1 plus 1, then 2. If 1 minus 1, then 0. But from 2 and 0, सिर्फ 2 ही हमारे सेट A का पार्ट। सेट A is 1 2 3, right? 0 is not a part of this set, so we don't have 0 as an answer. So the answer is x comma y. X is 2, then y is 1. Okay. If y is 2, then x can have again two values. One is 3 and one is 1. So 3 and 1 both are possible in set A, right? See, in this case, we got 1 and 3, but 1 and 3 both are possible in set A, right? So we have two possible answers for this part, 1 comma 2 and 3 comma 2. Now put y is equals to 3. The answer would be 3 plus minus 1. 4 and 2. Again, 4 is not a part of the set A. X and y both has to be from set A. So we will ignore the 4 and the answer would be 2 comma 3. So the whole relation contains these 4 elements. The final answer must be 2 comma 1, 1 comma 2, 3 comma 2 and 2 comma 3. Please feel free to discuss your doubts. If you didn't understand any of the step, तो पूछ लो. But करना हर बार यही है. Give a value of y, find out all the possible values of x, check करो वो set को belong करती हैं कि नहीं जो भी given relationship है, and find out the answers. Okay, let's solve this one. This is y, by the way. So x is greater than mod of y minus 2, and x and y both are from set A. Again, you know what is set A, and this is modulus. If you don't know what does modulus do, then understand it like this, that modulus always gives us the absolute value. So let's say if there is a negative value inside a modulus, its job is to make it positive. So if we are applying modulus on minus 2, then the answer would be 2. If you are applying modulus on a positive value, then it doesn't affect that. The value is 3 itself. Right? So the job of modulus is to give you the absolute value, positive value, only the value without sign. So if there is a positive sign, then you don't need to do anything. If there is a negative sign, it will convert it into a positive sign. Right. Now you have to form this relation R. Please try to solve, everyone. I'm expecting some of you to answer this.
Sir, set is 1, 2, 3.
Just a minute. Yes, set A is 1, 2, 3. No Shahid, no Faiza. I mean, the answer is incomplete. Faiza and Shahid, both of your answers incomplete. All the written pairs are correct, but there are more to find. Austin, the answer is correct. Good. If the value inside mode is 0, then the answer is 0. Yeah, now it's correct. Yeah, what about Shaviz, Tharif, and Faiza? Now, Faiza, you were solving it in a correct, I mean, you're solving it the correct way. Just put more values, no? You've only given y as 1. So now put y as 2. Exhaust all the possibilities. We have, in the set A, we have 3 possible values, right? 1, 2, and 3. So let's start again. If y is 1, then your x should follow this relation. X should be greater than 1 minus 2. Now the mod of 1 minus 2 is 1 minus 2 is minus 1, right? And mod of minus 1 is 1. So x should be greater than 1. If x is greater than 1, then there are two possible values of x, 2 and 3. From the set A, there are two possible values of x. Right? Now, let's put y is equals to 2. Okay, the answer from this case will be x comma y. So the ordered pairs are these 2 comma 1 and 3 comma 1. Now try to solve this for y is equals to 2 and y is equals to 3. All of you. I mean, barring Austin and Shahid. तीनों लोग सॉल्व करो यार इसको y2 और y3 के लिए. अब बताओ क्या क्या पॉसिबल आंसर्स आ रहे हैं. Faisal, what are the answers for y is equals to 2?
Can I tell?
But 0, yes.
Sir, the possible values for y is equal to 2 is 1 comma 2, 2 comma 2, 3 comma 2.
Correct. So Faisal, in this case, x is greater than, x must be greater than 0, no? If this is 2 minus 2, we put y as 2, then the equation becomes x greater than mod of 2 minus 2. Now x greater than mod of 2 minus 2 means x greater than 0. I mean x greater than mod 0. What is mod 0? 0. So x should be greater than 0. What are the possible values of x? 1, 2, and 3. And all of them are greater than 0. No? So the answers for this, x can take the all the values 1, 2, and 3, and hence there will be three ordered pairs. One will be 1 comma 2, then another would be 2 comma 2, and the last would be 3 comma 2. Did you understand it? Okay, solve for y is equals to 3, and Tharif as well. Tharif, solve it for y is equals to 3 in the similar fashion. Or either ask me questions, yeah, no, your doubts. Did you understand this or not?
Yes, sir.
No, I am talking about Tharif, Muhammad Tharif.
Yes, understood.
Okay,
Yes,
so
sir.
find out the values for y is equals to 3. Yeah. Yes, what are the possible values of x? What is the equation? Did you solve the equation? It's correct. Now, if y is 3, the equation becomes x greater than, we have this rule, right? We are applying the values in this rule. So if we put y is equals to 3, then it becomes this. Then 3 minus 2 is 1. And what is mod 1? Mod 1 is 1. It changes the sign if the value inside is negative. And it keeps it the same if the value inside is positive. If it's 0, then it's 0. So x must be greater than 1. What are the possible values? 2 and 3. So answer from this case would be 2, 3 and 3, 3, right? Correct. Every one of you is correct. Harif, please feel free to ask me if you don't understand anything. But you need to solve these because after, if you won't be able to solve them, if you won't be able to form a relation, then how would you find out the type of relation? Because the type is totally associated with first forming the relation. So पहले बनाना पड़ेगा relation. After that, we will be able to find out which type of relation it is. Okay. So in this case, our relation is 2, 1, 3, 1, then 1, 2, then 2, 2, then 3, 2, then 2, 3 and 3, 3. This will be the complete answer. Okay, now let's understand which type of relations we have and how do we define these types of relation, right? So there are 3 kinds of relations that we can form or that we can categorize a relation into. So types of relation have 3 categories. One is reflexive relation. Then second is symmetric relation. And then your third is transitive relation. First, understand this part in a very basic sense, and then we'll come to the technical definitions and all. Okay. So let's say one relation R is given, right? So let's talk about this relation only. Okay. And this was formed on the set A, right? Here X and Y both were from set A. So the set A was 1, 2, 3. Okay. And it was formed on set A, 1, 2, 3, this relation R. Now it can be categorized into 3 parts. First is reflexive, second is symmetric, and third is transitive based on certain qualities. Now, first understand what is a reflexive relation. So let's say this relation R is formed on the set A. Set A contains 1, 2, 3. Now, reflexive suggests that every element should reflect itself. Every element should reflect itself, Mane. When you write this relation, no, 2, 1, 3, 1, 1, 2, 2, 2, 3, 2, 2, 3, 3, 3. Then this ordered pair is divided into two parts, domain and range. Or you can also understand, let's start creating a basic understanding of domain and range. So domain is basically your input, right? And range is your output. Input is your first element of the ordered pair. Whatever first element is written in the ordered pair, that is your input, or you can say domain, right? And output or range is your second element of the pair. So for example, for this relation, there is 2, 3, 1. I mean, this 2 is your domain. I will just give me a minute. Yeah, so I will put this on domains. This is domain, this is domain, this is domain. These are inputs. If you give input 2, you are getting an output 1. If you give input 3, you are getting an output 1. If you give input 1, then you're getting an output 2, right? So these first elements are your inputs or domain. So basically these are the elements of domain. Now 2, 3, 1, then again 2, 3, 2, 3. There are multiple 2s and multiple 3s. But if I write domain, then this is the set of all first elements, which are 1, 2, 3 basically. You can observe that 2 is repeating itself and 3 is also repeating, but that doesn't change our set because domain is the set of all the inputs. Set of all the inputs. And input is basically your first element. Then range is set of all the outputs. So your outputs are 1. First two outputs are 1, then 2, again 2, then 3, right? So in this case, these are my outputs. But again, the set of output is also 1, 2, 3, right? So when I say that every element should reflect itself, now coming back to the reflexive relation, what is reflexive relation? That we are saying that every element should reflect itself. It means that every input has the same, every input should have the same output as well. I mean, if 1 is the input, then 1 should be the output. If 2 is the input, then 2 should be the output. If 3 is the input, then 3 should be the output. So if you want to say that a relation R is reflexive on set A, it means that that relation should contain 1, 1, 2, 2, 3, 3. For each element involved in the set A, there should be the same output as well. So if I'm saying that a relation is reflexive, then it means that the relation is basically following this condition. Let's use this one. So reflexive is a relation R sorry, yeah, a relation
Sir,
is
here there is one set, so in the one set only there is both domain and range.
yeah. It doesn't matter. Domain and range will be for I mean, it doesn't depend on the set. The element and the elements of domain are from the particular set, and elements of the range is also from a particular set, and that set can be same, right? So it doesn't matter that there are two sets involved or one set is involved, but however sets are involved, in general, there will only be one set. Like there will be set A only. In general, this will follow, but if there are two sets given and you need to form a relation, then you can also form that. But in general, you'll be performing all the relations, I mean rules of relations on a set A, on one set only. Right, Shavis? Was that your question or something else?
No, yes, this one.
Yeah, okay. So in this case, a relation R on set A is called, you should write this line before starting in the reflexive relation or symmetric or transitive. So we are talking about a relation R, which we have formed on a set, on a particular set. Let's call that set as A, and let's call the relation as R. So then the relation R on set A is called reflexive if R contains A comma A So if A comma A belongs to R for every A, small a, belongs to set A. No, just give me a moment. If A comma A belongs to R for every A belongs to A, capital A, right? So here we are saying that if a relation R is written on set A, right, and set A contains some elements, then each element should be connected with itself, right? Each element should reflect itself. Just give me a minute, guys. Yeah. So for every small a belongs to capital A, your A comma A belongs to R. So in this example, if you understand, let's say for the set capital A 1 comma 2 comma 3, if you are writing a relation and that relation contains 1 comma 1, 2 comma 2 and 3 comma 3, हर एलिमेंट खुद से कनेक्टेड है उस रिलेशन के अंदर, तो बोल देंगे उस that particular relation is reflexive relation, right? We'll understand it by this example only.
Sir, like
And
both the elements should be same.
yeah, both the elements should be same and they should be true for all the elements. मतलब ऐसा नहीं कि अगर सिर्फ इसमें जैसे let's take this relation only, right? Now in this relation there is a 3 comma 3 present, right? There is a 2 comma 2 also present, but we don't have 1 comma 1, right? Now there are two of the pairs which we need are present, but one pair is not present. So we will say that the relation is not reflexive because each element is not connected with itself. There is one element which is not there, which is not following the rule. Hence the relation is non-reflexive, right? But this rules will, but this particular rule will slightly tweak for the symmetric and transitive part. Now for, if I say, let's understand the symmetric part also. Let's say I have this two value A comma B, right? If A comma B follows this relation R, then B comma A should also follow R. Then it will be called symmetric. And you can also understand the meaning of symmetric because they are basically a mirror image of itself. 1 comma 2 and 2 comma 1. They are mirror image of itself. They are symmetric in nature. So for a particular given pair A comma B, B comma A should also be present in the relation. If the relation is following this rule for all the pairs inside it, then the particular relation will be called symmetric. Otherwise, it's non-symmetric, right? Now let's understand for this relation only, which is given in this. So we are trying to find out whether this relation is reflexive. We have already found out that this relation is not reflexive because it does not contain 1, 1. Now coming to the symmetric relation, how to check symmetric relation? You take first, you start from first pair. There is 2, 1. So if this relation is symmetric, then 1, 2 should also be present. If it's there, then we will check for the another part. I mean another pair, and we will try this out on each pair. Right? So let's take 3, 1. Then for 3, 1, 1, 3 should be there. Now you can see that there is no 1, 3 here. Hence, this relation is non-symmetric. If there is one pair which is not following the rule, then the relation is either non-reflexive or non-symmetric. Right? But for reflexive, we are taking the elements from the set. We're taking all the elements of the set. But for symmetric, we are not taking the elements from the set. We are just checking out all the pairs of this relation. So let's say if this contains 2, 1, we are checking out for 2, 1 only. If it does not contain 2, 1, I will not check for 2, 1. Right? So this is the basic difference between reflexive and symmetric relation. Now let's come to the transitive relation part. Then yeah. For all A, B belongs to R. Now let's understand transitive also. So let's say there is a pair A, B. Now we should write it like implies that. This is a better representation. So yeah. So if A, B belongs to R, and there is another pair which starts from B now and ends at C, that also belongs to R, then it should imply that A, C also belongs to R. Right? For all A, B, C belongs to. Now let's understand transitive also. So let's say I want to check for transitive. Okay. So I'll take a pair first, 2, 1. Then for 2, 1, I will try to find out a pair which starts from 1. If this 2, 1 is ending on 1, then I will search for a pair which is starting from 1. Now in this case, there is a pair 1, 2, right? Then if 2, 1 and 1, 2 is there, then 2, 2 should also be present in the relation. So for transitive, I will take a pair A, B, then I'll search for that pair. If there is another pair present, which is starting from the same element at which the first pair is ending, right? If there are two pairs following this condition in your relation, then it must follow A, C, right? If it exists for every pair, then the relation is transitive. If it not, then you can't say that the given relation is transitive. So for 2, 1, let's start with 2, 1. We have 1, 2, right? There is another pair which starts from 1. 2, 1 का end हो रहा है 1 पे, तो 1, 2 का start हो रहा है 1 पे, right? So in दोनों pair, if I combine these two pairs, because they form a pair according to the condition. If there is no condition, then I will not go for it. It's transitive. I mean, if this first condition is not following, that if there is no element which starts from B, then A, B is transitive. I mean, it doesn't have the required pair. And how can you say that it's not transitive? Right? So if I start with 2, 1, तो मैं पहले check करूंगा कि कोई ऐसा pair है जो 1 से start हो रहा है. And if there is one pair, then I will try to take the first element of first pair and second element of second pair. So 2, 2, which is also present in the relation. This is here. So ठीक है. Now I'm good. I will take another pair, 3, 1. Then I will again check if there is a pair which starts with 1, because this pair is ending at 1. Again, 3, 1, 1, 2. They again form a pair. And from 3, 1 and 1, 2, I can take 3, 2, right? Which is here, which is again present in the given relation. So till now, the relation is transitive. Now I'll come to 1, 2. I'll do it for each pair. 1, 2. Then there are elements which are starting with, there are pairs which are starting with 2. So for 1, 2, I have these following pairs. You can also check these. For 1, 2, you have 2, 2. Then you have 2, 1. Then you have 2, 3. For this to be transitive, you should have 1, 2, first element of first pair and second element of second pair. For this, you should have 1, 1. And for this, you should have 1, 3. You can see that you have 1, 2, but you don't have 1, 1 and 1, 3. Right? Means the given relation is also not transitive. So this is how you can check for these types of relation. Follow the simple rules. For reflexive, take the element from set. All the elements of the set should be connected to itself. For symmetric, if there is an element, then its symmetric should also be there. And for transitive, find out first two pairs which follows the condition that where one pair is ending, the another pair is starting. Right? If there are certain, if there is you have these conditions, then apply the rule A, C should also belong to R. Right? Now let's check these conditions on some relation. You try to check whether these given relations are reflexive, symmetric, or transitive or not. So A is given to you 1, 2, 3, 4. Consider a set A. And for this set, form some relation, not form. Just check whether a relation is given to you x comma y such that x is equal to y plus 1 and x comma y belongs to A. Form this relation first, then check whether the relation is reflexive, symmetric, or transitive or not. First form these relations, then only you will be able to check.
Sir,
Yes.
in transitive also for all pairs, this condition should be applied.
Yes. For all the pairs given in the relation, a condition should apply. You try this one, it will be clear to you after the. Guys, start solving these two questions and give me 2 minutes.
Sir,
Yes.
the first one is, I think, sir, not reflexive, symmetric, and transitive.
Okay, what's the answer? But what is your relation first of all?
2 comma 1, 3 comma 2, 4 comma 3.
2 comma 1, correct. 3 comma 2,
4 comma 3.
4 comma 3, correct. Now it is clearly not reflexive because it does not have 1 1 2 2 3 3 4 4, right? For reflexive, each element should be connected to itself, right? तो हमारे पास 4 एलिमेंट्स थे 1 2 3 4, हर कोई खुद से कनेक्टेड होना चाहिए, मींस दैट 1 1 2 2 3 3 एंड 4 4 should be there. अभी एक सेकंड रुको यार, जस्ट वेट अ मिनट. Okay, so this is our 2 1 3 2 4 3 is our relation. To check reflexive, every element should be connected to itself, but it is not the case. So not reflexive. Now coming out for the symmetric part, let's take 2 1 first. For 2 1 1 2 should be there, which is not present in the given relation. Hence, just on the basis of the first pair only, you can say if this is not following the condition, then we don't need to check for others. We just want one pair which does not follow the condition, which break the rule. Hence, it is not symmetric. And let's come to the transitive part. So 2 1 के लिए we need some element. Okay, transitive, please check. 2 1 we need another pair which starts from 1. अभी 2 1 को चेक करने का है, तो मेरे को ऐसा पेयर ढूंढना है which starts from 1. Why, Faiza? Shaviz, why is this relation not transitive?
So because there's no other element which starts with 1.
So, but that doesn't break our condition. If we have both, I mean, if first of all we have to satisfy the given condition, no? A comma B should contain B comma C. Then A comma C will be checked. If it's not there, then the given relation is transitive. So we don't have any pair which starts from 1. It means that the given pair 2 1 is a transitive. I mean, this does not break the transitive condition. This is following the condition because you don't have any pair which starts from 1. But 2 1 ने तो कोई condition break नहीं करी ना. So it is still transitive. 3 2, we don't have any element which starts from 2, or do we have? No, check for 3 2 now. 3 2 we have 2 1. We will check for each element, no? So for 3 2 we will try to find out a pair which starts from 2. There is a pair which starts from 2 1. So combined they should also have 3 1, which is not there. Now it's not transitive. So understand the difference. This is not transitive, not because of the first pair, because of the second pair. Right? We don't need to check for 4,3 now. Correct, Faiza? Good. Now, what is the second relation? First of all, tell me this. कोई भी बता दो. What is our relation? अरे,
So 1, 2, 2, 3, 3, 4, 4.
correct. 1,1, 2,2, 3,3, 4,4. So this was the first part. Now let's solve second part. So our R is 1, 1, right? 2, 2, 3, 3, and 4, 4. Now let's check first for reflexive. Tharif, is it reflexive?
Yes, sir.
Is the given relation reflexive? Second one.
I think so.
What about Austin? Is the given relation reflexive?
Yes, sir.
Okay. Because this contains 1, 1, 2, 2, 3, 3, 4, 4, right? All the 4 elements which were there in set A, 1, 2, 3, 4. Every element is connected to itself. So clearly this relation is reflexive. 1, 1, 2, 2, 3, 3, 4, 4. Now let's talk about symmetricity. So 1, 1 ke liye symmetric. If I check for 1, 1, then the symmetric pair is again 1, 1, which is present. 1, 1 का symmetric तो 1, 1 ही है, वो तो already है. And similar are the cases for 2, 2, 3, 3, 4, 4. If you take any element, its symmetric is also the same, which is already there. So symmetric, yes, it is also symmetric. Shahid and Chavez, did you understand this? The given.
Yes, sir.
Okay.
Sir, it's 1, 1, so it's symmetric.
2, 2 is also symmetric with 2, 2. 3, 3 is also symmetric with 3, 3. 4, 4 उल्टा करेंगे फिर से 4, 4. वो तो है ही ऑलरेडी हमारे पास 4, 4.
Okay, sir.
Abhi now let's check for transitive. वन वन कंपेयर करने के लिए there is no other element which starts from 1 1. I mean 1 1 ही है. If you take 1 1, transitive check करना है. So I will take first pair 1 1. I will try to find out how many pairs are there which starts from 1. There is only one pair, 1, 1. And if you take both of these, then the answer is 1, 1 only. Similar is the case for 2, 2. There is no other pair than 2, 2 which starts from 2. Similar is for 3, 3, 4, 4. So all the 4 pairs are following that condition. Hence it is also transitive. Reflexive, symmetric, transitive. This particular relation is following all the conditions. Before we proceed, please feel free to ask your doubts. First, clear your doubts, then only you'll be able to start with the next questions.
Sir, can you just explain how is it transitive in the second one?
Yeah. So how is it transitive? For transitive part, we are taking, see, we are again going one by one, right? We will take one pair और हम उसके लिए चेक करेंगे ऐसे कितने पेयर्स हैं जहां पे वो पेयर एंड हो रहा है वहीं से ही वो सेकंड पेयर स्टार्ट हो. So let's take 1, 1. So for 1, 1, I will have four options: 1, 1, 2, 2, 3, 3, 4, 4. Out of these four, only 1, 1 is there which starts from 1. या तो ऐसे देख लो या फिर ऐसे either you can check it in this way or you can simply say that 1, 1 does not have any pair which starts from 1. मतलब 1, 1 के लिए कोई दूसरा पेयर ऐसा है ही नहीं जो 1 से स्टार्ट हो रहा हो अदर देन 1, 1. तो या तो आप 1, 1 पे अगर 1, 1 को ही लगाओगे तो भी देखो ट्रांजिटिव आ ही रहा है क्योंकि वहां से भी आंसर 1, 1 ही है. बट अगर आप वो भी नहीं लगाते हो, आप ऐसे देख लो, फिर दूसरा तरीका ये है कि 1, 1 के लिए कोई दूसरा पेयर ऐसा नहीं है 2, 2, 3, 3, 4, 4 जो 1 से स्टार्ट हो रहा हो, तो आप 1, 1 को चेक ही नहीं कर पाओगे, राइट? एंड इन दैट केस वो ट्रांजिटिव है क्योंकि उसके लिए कंडीशन ही पहले फुलफिल नहीं हो रही. हाँ जी, फायजा शावेज समझ आई ये बात?
Yes, sir.
व्हाट अबाउट फायजा? ओके, ठीक है. So yeah, now one more thing is, Austin, did you understand this reflexive, symmetric and transitive?
Yes, sir.
Okay, now the next part is that if a given relation is reflexive, symmetric as well as transitive, then we say that the given relation is equivalence relation. If a relation follows all three conditions, reflexive, symmetric and transitive, then we say that the given relation is equivalence relation. Okay, now let's solve some problems from the NCERT itself. Just give me a minute. Okay, let's come to the page number 5, exercise 1.1. And let's start with the third part. First question, third part. So you are given R in set A. We have to form a relation R in set A. Set A consists 6 elements: 1, 2, 3, 4, 5, 6. Right? And relation is formed as R is a relation of the ordered pairs x, y, where x and y follows the condition that y is divisible by x. Y is divisible by x. First form this relation and then check out whether the given relation is reflexive or symmetric or transitive or not. एक भी condition, if there is a single condition which or single pair which does not fulfill the condition, then we say that the given relation is not reflexive or symmetric or transitive. एक ही pair चाहिए बस. एक बार भी अगर rule break हुआ, then we can say that the given relation is not, जो भी आप, whatever thing you are calculating. So first form the relation and then you'll be able to check better. We also have one more variety of questions where you can't just simply form the relation. जैसे यहाँ पे तो अभी आपके पास you will have pairs. After solving this, you will get pairs, right?
But there will be some questions in which you won't get pairs. So what you will do is you will try to find out whether the given condition, whether the whether the given whatever the condition is given inside the relation, whether that is false for even a single pair. अगर एक भी पेयर ऐसा मिल जाए जिसके लिए वो false हो जाए तो बस you can easily say that the given relation is not this or this or this. Anji, anyone? What is the relation, first of all? Let's take y1. If y is 1, then 1 is divisible by x. You have to find all the values which can divide 1. There's only one value that can divide 1, which is 1. No? So let's take, yes, just a minute. Correct, Faiza. Correct. The relation is correct, Faiza. Very good. So if you take y1, then x is also only have one value, which is 1. If you take y2, then x can be 1 or 2, because 1 and 2 both divides 2. So if y is 2, x can either be 2 or it can be 1. Right? And in the similar fashion, you can find out all the possible values. So if you take 1, 3 or 3, 3, because 3 only divides 3 and 1 divides 3. Right? Similarly, if you take y4, then x can be 1, 2 or 4. बेसिकली यही तो देखना है यार कि x is dividing y. x, y is an answer if x divides y. तो 1, जैसे 1 के लिए मैं अगर लेट्स से चेक करता हूं तो 1 के लिए कौन कौन से पेयर बन सकते हैं? इफ आप ऐसे सोचो x को 1 लो, let's start it thinking another way. If x is 1, then what are the possible values of y? Y should be divisible by 1. तो 1 से तो every value is divisible by 1, right? Similarly, if I take 2, then 2, 4 and 6 are the values that are divisible by 2. If I take 3, then 3 and 6. For 4, only 4, 5, 5, 6, 6. तो कैसे भी देख सकते हो, you can start the question either taking from the values of y or from the values of x. Both will give you the same answer. So let's say if I take y4, then x can be 1, x can be 2, or x can be 4. Now let's say y is 5, then 1, 5 and 5, 5. Only 1 and 5 divides 5. For 6, 1, 6, 2, 6, 3, 6. क्योंकि 1, 2, 3 and 6 all divide 6. This is our relation. Now we will have to check whether the given relation is reflexive, symmetric, or transitive. Faiza, before that, reflexive and symmetric. What about reflexive and symmetric? For reflexive, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6 should be there. है ना? It is reflexive. जो भी रिफ्लेक्सिव वाले एलिमेंट्स होते हैं ना 1 1 2 2 3 3 4 4 5 5 6 6 they are also symmetric and they are also transitive. They don't break any rule. You can just take them aside. Once you got a relation reflexive, तो आप ट्रांजिटिव एंड सिमेट्रिक का रूल उन रिफ्लेक्सिव वाले रिलेशंस पे मत लगाओ, मतलब उन पेयर्स पे मत लगाओ 1 1 2 2 3 3 4 4 5 5 6 6 को किसी के साथ भी चेक मत करो. Don't check them for symmetricity or don't check them for transitivity because they are already symmetric and they are already transitive. But only these pairs, I mean वो pairs जिसमें आपका दोनों एलिमेंट सेम हो. All the pairs in which both the elements are same, don't check them for symmetricity or transitivity. Okay, let's start checking from this 1, 2. If 1,
So it's
2,
not
2,
symmetric.
1. Yes, correct, because there is no 2, 1. राइट? तो 1,2 नो 2,1। तो एक ही एलिमेंट अगर मेरे पास ऐसा है जो 1,2 ऐसा है, so if there's a single element, right, which is not following the condition, 1,2 है तो 2,1 नहीं है, then I can say this is not reflexive. Now it is your task to check it for transitive. Okay, in the next class we will discuss about the transitivity of this given part. Okay, try to solve some questions from NCERT. Try to solve exercise 1.1. No, it is reflexive, Faiza, but it is not symmetric. Why it's not reflexive? Every element divides itself. No, so it has to be reflexive. This already you're showing you the reflexive nature. समझ आया फाइजा? रिफ्लेक्सिव होना चाहिए. See, it has to be reflexive, no? Faiza, am I audible? Because it contains 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. 1,